All right, guys. So what we're looking at here is the exam from 2020, 2021. When was that? Was that last year? Yeah. So you're looking at the exam from last year. No graphing calculator. I don't know if hopefully all of them did it without a graphing calculator. And because it was a take-home exam, I went ahead and allowed a 4-function calculator to do add, subtract, multiply, divide. Usually I don't allow that during class, but maybe we can make an exception. We'll see. First question. Looks pretty straightforward. It says determine the relation from set A to set B as a function. And we look at every element of set A. It is coming out. One is coming out of each element of set A. And I notice that there's an arrowhead on each element of set B for except one. So what does that mean if there's one that does not have this? Yeah, it's not onto. But is it definitely 101? Yeah, 101 function, but not onto. So letter C. Cool. And then number 2, I guess the first 3 are very simple. I guess the first 2 are very simple. Is it a function? Not a function. If I ask for a reason, you would say it does not pass vertical line test. You could also say X is repeat. Number 3, it says identify the domain of the function g of x equals 3 minus x over x squared minus x minus 20. So we don't pay any attention to the numerator. So I guess the number 1 question comes yesterday after school. Several were asking, why do we not pay attention to the numerator? But sometimes we do. Well, because you just have a general expression like 3 minus x. The domain of 3 minus x is all real numbers. So we're not paying attention to 3 minus x. We're paying attention to the x squared minus x minus 20 because that has numbers that I cannot divide by. I can't divide by 0. Does that make sense, guys? So I'm going to find my factors of that. 2 numbers that when I multiply give me negative 20 but adds up to negative 1.
Oh, negative 5 4.
Yeah. And then you just say what gives me a 0 in the bottom? Well, for sure 5 and negative 4. See, but those are numbers you cannot beat. If it were not multiple choice, you would just tell me all real numbers but those. But since I have, what is this called? Interval notation. Since I have interval notation, you got to go negative infinity until you hit negative 4. Union, negative 4 until you hit the 5. Union, 5 until you hit the infinity. So that is D. How do we feel, guys? Okay. On number 4, it says it is known that the point negative 2, negative 5 is the point on the graph of y equals f of x. Then which of the following points must be on the graph of, and they give you this function here. So that in the inside f of x minus 1, what does this make it do? What does the x minus 1 do? Not left.
Oh, right? Oh my god,
Moves 1 unit right. So negative 2, 1 unit right is between B and E and C. So what does that 3 do? 3 units up. So negative 5 plus 3? There you go. All right, on this question, guys, it says, in the graph to the right, the dashed line graph represents f of x. So I have a dashed line, that's f of x. And a solid line represents g of x. So this solid line represents g of x. If you want to use different colors, go for it. Now, which of the following values of x is f of x less than 0? This is just a fancy way of saying negative. And f of x less than g of x. So I want f of x to be negative. So I'm looking between some number like negative 0.75 all the way to 4. Well, I guess they give me Roman numerals here. So I guess let's just look at that. At x equals negative 1. At x equals negative 1, f of x is positive, so that one's out. Do you guys see what I did there, guys? And then at x equals 2, okay, f of x is below the x-axis and g of x is above. And g of x is bigger than f of x. That's what this means. So that one works. And at x equals 4, f of x is equal to 0. So just Roman numeral 2. We want f of x to be negative. It must be negative. And that's it, guys. Are we okay? What does it mean to be odd? Yeah. Symmetric about the... No, not the y-axis. Not the x-axis either. No. No, because those are... y equals x, it would be an inverse function. And I had to actually stop for a little bit and like, wait a minute. And like, no, it wouldn't work. It's, yeah. If you take like x cubed, which is an odd function, and you reflect it, it would not reflect across the line y equals x.
Oh, it's the origin.
Symmetric about the origin, guys. Travis, what does that even mean? That means something is translated 180 degrees with respect to the origin. This is not official, but I don't know, I guess you guys tend to like the unofficial names. Flip, flip. Don't go to a professor and say, oh yeah, flip, flip. If you take the x-axis and y-axis and you go to negative 3, 2, negative 3, 2, and it doesn't even matter what axis you do it with. So reflect it across whatever axis you want, and then reflect it again across the axis that's remaining. So if you flip it across the y-axis, you're here. If you flip it across the x-axis, now you're down here. What is that coordinate? It's going to be 3, negative 2. It doesn't matter. I could have gone across the x-axis, I'm here, and now across the y-axis, I'm back. Flip, flip. Are we okay? When was the last time you guys heard about even and odd? 7th grade, 8th grade? Okay. Alright, so we'll just put, I don't know, I had the exam finished on Saturday, and then yesterday I decided to tweak it, and I deleted 4 problems and added 2. So more than likely, knowing how I am, how I'm always thinking about questions, I'm probably going to delete another 2 or 3 and then add another 2 or 3. But they'll be similar. If you understand the concept, you'll be fine. If the g of x equals that expression, and f of x is the function pictured to the right, then what is the value of f g of 3? This is a composite function, guys. Always work with the inside first. So do g of 3 first. G of 3 equals square root 2 times 3 plus 3. All that dude is divided by 3 minus 4. And let's see what that gives you. 2 times 3 is 6. 6 plus 3 is 9. Square root of 9 is 3. So 3 over negative 1. So you get negative 3. Now what? Take this value, put it inside of f. This graph is f. So go to negative 3 and see what y value I have on that curve. That looks like a what? Yep. Negative 4. And that's it. All right. I have another one just like this. Same concept. I give you an equation and I give you a graph and doing the same thing. For questions 8 through 10, use the graph of f of x pictured slightly below and to the right of this text. So this is f of x. Which of the following statements is true? So the numbers here on the right hand side, guys, what's smaller, what's bigger? Yeah, what number, are they arranged smallest to biggest? Are they arranged biggest to smallest? What does this mean? F of negative 1 less than f of 5 less than f of 3.
values, they want to be like smaller.
Yeah. Thank you, man. So I want smallest to biggest. So it looks like they're just looking at f of negative 1. And look, it's the same values over and over again. F of 5.5 and f of 3. So let's figure out those values really quick. F of negative 1, I go to negative 1 and I get a negative 2. F of 5.5, I go to 5.5 and it looks like negative 4. And I go to 3 and it looks like f of 3 is 2. Which one's the biggest? F of 3. So I should see that one on the left or the right hand side? Yeah. So delete B, D, and E. The right is bigger than the left. So it's between, let's see, which one's next? So there it is. In a number line, guys, the further left is considered smaller. And I know in physics it's different, but like negative 1 million is considered small as opposed to like 5. Now I know in physics it's just magnitude, it just means direction. That's what you call a vector. Have you guys already covered vectors and scalars? Okay. Yeah, physics is just math. Alright, so here we go. Which of the following statements are false for the graph of f of x? The domain of f of x is negative 5 to 6. So let's see, negative 5, parenthesis to 6, solid. That is a true statement, so because it's true, delete it. So they want one that is false. The range of f of x is negative 5 to 6. All right, so let's see, negative 5 down here. So far that is true. 6 up there. That is false. So that one is so far one of my answers. And then f of x equals 2 when x equals 1. That means f of 1 equals 2. So is that a true statement? Yeah, so that's not what I want. So it's just what? Yep. Let's keep going. Oh, this is one of my favorite ones. Very little students got this one right. I was kind of sad when we did this one last year. It says suppose g of x equals negative square root of x plus 3 plus 2. For how many values of x is f of x equal to g of x? So I was hoping, at least I was hoping, that they could tell me how that graph looks without a calculator. Can you guys tell me how that graph looks without a calculator? Yeah, it's reflected across the x-axis, right, because of the negative on the outside. And I shift 3 times to the left and 2 times up. So let's go to this right here, and I'm going to put it in blue. So from the origin, I go 3 to the left, 1, 2, 3, and 2 times up. 1, 2. Put a point there. And all I'm doing is putting random points, guys. The square root of 1 is 1. So if I go 1 to the right, 1 down, I should have another point at negative 2, 1. Travis, how'd you get that? The square root of 1 is 1. So remember, I'm reflected. It's square root of x, but I'm reflected. So cool. The square root of 4 is 2. So if I start at negative 3, 2, move 4 to the right, 2 down. 1, 2, 3, 4, 1, 2. You should have another point at 1, 0. And then the next square root, the next biggest square root is square root of 9. So square root of 9 is 3. So start at your end point at negative 3, 2. Go 9 to the right, 3 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Point. And you can kind of see your square root function take shape. There's my square root function in blue. How many times does the blue line or blue curve intersect the black curve? Twice, that's it. And last year when I gave this, for them to get full credit, I had to see that drawing. If they just guessed 2 by luck, I did not give them any points. Yes, so it all comes from this graph here. I know that I have a point at 0, 0. I know that I have a point at 1, 1. because the square root of 1 is 1. I know that I have a point at 4, 2, because the square root of 4 is 2. And then I know that I have a point at 9, 3, because the square root of 9 is 3. And because I know that I'm reflected across the x-axis, I have no vertical stretch because there's no number in front. I just have a negative there. So from the endpoint, I'm just like, oh, okay, I'm reflected across the x-axis. So if I scroll 1 to the right, I can go 1 down. If I go, let me choose a different color here, green. If I go 4 to the right, I can go 2 down because the square root of 4 is 2. And if I go, let's use burnt orange for UT. If I go 9 to the right, I can go 3 down. That makes sense?
Yeah.
You could always just do a table if you want. You could always just go x, g of x, and if you plug in negative 3, you're going to get a 2. Negative 3 plus 3 is 0, square root of 0 is 0, plus 2, 2. 1. 1 plus 3 is 4, square root of 4 is 2, but there's a negative on the outside. Negative 2 plus 2 is 0. And what is that, 6 over there? 6 plus 3 is 9, square root of 9 is 3, but there's a negative. Negative 3 plus 2 is negative 1. So you could always do a table. So there's so many ways to do it, guys. It's like, if you understand the concept, you're golden. Don't be a machine. Okay, I deleted this one, but I really like it. Oh, don't sigh, guys. I heard someone sigh. I really like this question. Let me tell you why. There are entrance exams that I've seen that they ask a very similar question. Sometimes they're just very blunt. They'll just say complete the square. So even though I'm not gonna ask this question. Is it still okay if we go over it real quick? Okay. So this says state the corner to the vertex of the parabola. So hopefully when you were in Algebra 2, they did vertex form. And vertex form looks like this, where the vertex is h comma k. Cool? Now, if I want this, remember guys, we have no calculator. So this is a common question for no calculator math entrance exams, or something very similar to it. Sometimes they're very blunt and they just say complete the square. So I want this expression to look like that expression, so I can find where my vertex is. Now, if you have a calculator, you can just cheat and find where the vertex is. But so here we go. I'm going to write 4x squared minus 24x plus 43. I'm going to take the first two terms, and I'm going to factor out a 4. So I'm going to write x squared minus, how many times does 4 go into 24? 6x plus, put a space, like so. I haven't changed anything yet, guys. So this is called completing the square. I take this number, the 6, and I divide it by 2. That's that b over 2 that you guys get. 6 divided by 2 is 3, and then I square it. 3 squared is 9. So that's magic. I just made it heavier by 36. 9 times 4 is 36, right? So I'm going to subtract 36 to balance it out, just like in Chem. And now, here's what I have. 4, this trinomial there reduces to x minus 3, close it with a square on it, plus the difference between 43 and 36, 36, 37, 39, 44, 52, 53, 7. So where's my vertex located at? 3, 7. And that's called, in case you need to know what that method is called, it's called completing the square. If you want to Google it later on tonight. Yes. Yes, I added this magic number 9, so I just made this side of the equation heavier by 36, because 9 times 4 is 36. So I needed to balance it by putting a minus 36. Your teachers maybe probably put like plus 36 on the other side or something, but we're working with the right-hand side. What's up, miss? Why did I choose to square the what? Oh, it's always this middle term divided by 2. Always, always, always. Whatever that is, you square it. 6 divided by 2 was 3, and then you square that number. We're going to give you another opportunity to see if we can do that, guys. Number 12. This question is in there again. I just changed the equations. So this one, that means f composite of g of x. That's what that means. So f composite of 5x minus 2. Now remember guys, f of happy face literally just means happy face squared plus 2 times happy face. So if I have the expression 5x minus 2, that's what I'm going to put in. 5x minus 2 squared plus 2 times 5x minus 2. Cool? And then from there you just, let's see, can we do that really quick? 5x times 5x, 25x squared. 5x times negative 2, that's negative 10x, but you're going to have how many of those? So minus 20x. Negative 2 times negative 2, positive 4, and then plus 10x minus 4. The 4's cancel out, or 0 out, I should say. And then those combine, and you'll get 25x squared minus 10x. ¿Estamos bien? Okay. This means, that means what? It's the inverse. So that 3 is an x coordinate on my inverse, which was a y coordinate on my original. So that was a y coordinate on f of x. So if it was a y coordinate on f of x, guys, f of some number equals 3, and I look for that number. What is that? Yeah, negative 6. There it is. That's it. We're almost done, guys. Question 14. I know it's not the most exciting thing here. That x plus 4, guys, is just 4 to the left. That minus 2 is 2 down. And that 5 is a vertical stretch by 5. So we look for that. What letter is it? Which one was it? I still don't see it. Letter D? Oh, nope. Letter E. Do you think we're pretty good that we don't have to do number 15? Can we skip it, guys? Okay. No? Okay, let's do it really fast. I need f of x plus h. X plus h squared plus 2 times x plus h minus 4. So here I am. I'm going to zoom in. So when I expand that, x times x is x squared. And you can drop the parentheses. There's nothing in front of it. X squared, and then x times h is xh, but there's 2 of them. 2xh, and then h times h is h squared, plus 2x plus 2h minus 4. Now I'm ready. So I'm going to write f of x plus h minus f of x all over h is equal to, and I'm going to write this first, x squared plus 2xh plus h squared plus 2x plus 2h minus 4 minus, and then I'm going to write what f of x was. This guy right here. X squared plus 2x minus 4. All this is over h. I'm going to distribute that negative, guys. I'm going to distribute that negative. So here's what I have now. And I guess you don't have to write it again. I choose to. But you don't have to. Minus x squared minus 2x plus 4. Let's cancel stuff out. Let's zero stuff out. I have a positive x squared and a negative x squared. I have a positive 2x and a negative 2x. Negative 4, positive 4. Finally, you have 2xh plus h squared plus 2h all over h. And if you want to cancel out one of the h's there, that's fine. I like to factor it out first. And there it is. 2x plus h plus 2. Cool. Now number 16, I canceled it out. But let's see if you guys can walk me through what we did earlier. You guys ready? They literally just bluntly tell me complete the square. So here it is. Negative 4x squared minus 40x minus 85. What do I do first? Factor out a negative 4 from the first two. Perfect. X squared plus, what's that, 10x? Plus a third blank. We haven't done anything yet. So, well, yeah, so 10 divided by 2. So we skipped, you guys are going, you skipped a step. Well, you probably already did it, but 10 divided by 2 was 5, and 5 squared is 25. So then, what did I do? Negative 4 times 25 is negative 100. So I got to balance it out by putting plus 100. Perfect. So now I have negative 4x plus 5 squared plus 15. And there it is. And I know, like I said, it's not part of the exam, but I want to show you guys something. So just bear with me real quick. I want to show you that it means the same thing. So I'm going to take out my little calculator here. Why what? Ask so I can answer your question. So check it out. Negative 4x squared minus 40x minus 85. Negative 4x squared. I already forgot it. Can you hook me up with it, Villacana? Minus 40x. Minus 85. And then what did I have on y2? Oh. And then I had negative 4 x plus 5. All right, guys, real quick. So I just want to show you guys that they're equivalent. Do you see y1 and y2? That's what I had initially. And then y2 is when I completed the square and I got this in vertex form. So if I go to, well, I think right now I don't have it in auto. Let me go to auto. If I go to my table, check it out. They're the same at every single value. Because it's the same. They're supposed to be the same. If they're not the same, then it wouldn't work. Cool? So if you graph both, the parabolas will look the same. One is, what is this called again? Vertex form? Okay. That's called vertex form, guys. Okay. 17. And we're almost done. So this has the square root of x plus 1 over x minus 6. Why am I paying attention to the numerator this time? Yeah, because it has a radical, guys. When you guys did domain and ranges of parent functions, you did the domain of a square root function, and you said that the domain was all numbers larger than 0, greater than or equal to 0. So it's the same deal. The expression on the inside has to be, the expression has to equal greater than or equal to 0, and we just solve for x. So x plus 1 greater than or equal to 0. So x greater than or equal to negative 1. But we have to also focus on that denominator, dude. You can't divide, you can't divide by 6. I would have accepted this if this were, if it didn't have multiple choice. You could say all numbers larger than negative 1, but it cannot equal 6. But since we have multiple choice, we can't accept it now, right? So bracket negative 1 all the way until you hit parenthesis, union, parenthesis again, 6 all the way to infinity. So which one is that? There it is. How do we feel? All right. Find the inverse of the given function. I notice, according to the UH quizzes, now I don't have statistical analysis because I'm not the owner of UH. But I've noticed on the ones that I've been looking at, the ones that you guys have been missing is a rational function. You guys seem to get the radical one correct almost all the time. But the rational function is the one that you guys have been missing. Guys, ask. Because only a handful of you have been asking. The others haven't. So how do I get this one correct? First, you toggle your x and y. So you're going to go x equals 2y plus 5 over y minus 3. Now, I don't want you to be a robot. You can trick me. On this one, you can trick me. I don't want you to be a robot. Why do we toggle the x and y? Because for an inverse function to work, you reflect across the line y equals x. So that's why we can just flip them and solve for a new y. Cool? Okay, so here we go. I'm solving for y. So to do that, I got to get rid of that ugly, well, it's not an ugly denominator, but we got to get rid of that denominator. So you multiply by y minus 3. Whatever you do to one side, you do to both. So I'm going to distribute now. So now I have xy minus 3x equals 2y plus 5. And now we're just going to, we want to get the y's on one side, guys. So we're going to have xy minus 2y equals 3x plus 5. And now that I have it looking like that, I'm going to factor out a y. So I'm going to have x minus 2 equals 3x plus 5. And what you're trying to isolate is the y. So if I'm trying to isolate the y there, you just divide by x minus 2. And that is your inverse. So you go f negative 1 of x equals 3x plus 5 over x minus 2. We're okay so far, guys? Too simple, right? All right. Suppose the point 7,4 lies in the graph of the function f of x. Here the function is transformed. So this is similar to the question on the first page. The only difference is that I have a vertical stretch in there. So let's see. That x plus 5 makes it move 5 times to the... What's that? Yeah, to the left. So it moves 5 times to the left. So take away 5 from that 7. What? So 2, right? Yeah. It's all good. It's all good, guys. And then I'm going to do a vertical stretch by what factor? 2. So that only affects the y value. So 4 times 2 is 8. And then I'm going to add 3. So 8 plus 3. There it is. So I'll go ahead and write it how we got it, guys. So what I did was 7 minus 5, comma, that's 5 to the left. And then we did 4 times 2 plus 3. So that 2 there is vertical stretch. And that 3 is up 3. So there it is. We feel pretty good so far, guys? Yeah, we're done. We're pretty much done. Yeah, because all the rest is just arithmetic. All right, find the linear function f of x which satisfies. So I have a coordinate, negative 7, comma, negative 10, and has a graph parallel to this line here. So first find this slope. Find m. So y equals negative 6x plus 5. We don't really care about that 5 there. That negative 6 is the one that we care about, guys. If we're going to be parallel, the slopes must be the same. The slopes must be the same if they're going to be parallel. So here we go. Y minus a negative 10, so that turns to a plus. I'm using my point slope form. Equals negative 6, parenthesis, x minus a negative 7, so that's going to turn to a plus. All I'm doing now is just solving for y. If it weren't multiple choice, you could actually leave it like that and we'll count it correct. Y plus 10 equals negative 6x minus, what's 6 times 7? And then go ahead and subtract 10 from that dude. And there it is. Cool. That's a cute smiley. All right, 21. Give the vertical asymptote for the graph So find all your factors, guys. In the numerator, let's see. Two numbers and multiply give you positive 8, but adds up to a negative 6. Both negative. In the denominator, two numbers that give you 16, but adds up to a negative 10. Which one and which one? Which ones? Yes. Yes. I thought I heard something else initially. Sorry, miss. Negative 8 times negative 2 is a positive 16, and negative 8 minus 2 is negative 10. What factors are going to cancel out? So I do not have a vertical asymptote at 2. You have a hole. But you definitely have a vertical asymptote at 8. Two more, and we're done. I have this graph. It crosses it has a horizontal asymptote, and it says if the graph crosses a horizontal asymptote, give the x-coordinate to the intersection. So the most common mistake that I see, guys, is that you guys circle letter A, probably because some teacher told you at one time you don't cross or something. No, you do cross. And there's several examples of rational functions that cross. First, find the horizontal asymptote. Just by looking at it, x squared. What's my horizontal asymptote, guys? 2. So set that expression equal to 2. 2 equals 2x squared plus x plus 3 over x squared plus 5x minus 10. And why are you doing that? Because if you're going to cross a horizontal asymptote, you need to set that expression equal to that y value of 2. Does that make sense? Yeah, if you're going to cross it, that's the only way. So I put a 1 in the bottom of that too, and all I'm going to do now is just what? Yeah, cross multiply. So 1 times the numerator there, so 2x squared plus x plus 3, better equal, and then 2 times my denominator there, 2x squared plus 10x minus 20. And now all you're going to do is solve. Your quadratic terms should always cancel. If it's going to cross, those terms will always cancel. Minus 2x squared minus 2x squared. Let's move the x's to the left. So minus 10x. I realize that's going to be a negative 9x. That's okay. And then I'm going to move my numbers to the right. So minus 3 minus 3. So that's going to be negative 23. And then we're going to divide by negative 9. Negative divided by negative is a we're going to have a lot of downtime, guys. So take advantage of your downtime. This is our last one. So here we go. Find the linear function f of x that satisfies, and I have a coordinate, negative 10, negative 2, and that is perpendicular to this graph. So first and foremost, find that slope first, right? So negative 8y equals 72x plus 1, divided by negative 8, divided by negative 8, divided by negative 8. Y equals negative 9x minus 1/8. We don't really care about the 1/8. We care about that negative 9. So in order for me to be perpendicular, what slope must I have? Perfect. My new slope must be opposite reciprocal, so 1/9. So here we go. Y minus a negative 2, so plus 2, equals 1/9, parenthesis x minus a negative 10, so plus 10. And I know some of you may be thinking, Chavez, I'm a pretty good test taker, and I just see 1 with 1/9. And, well, actually, there's 2 of them. But it's really easy to figure out which one it is. Anyways, on the test, I think I'm going to put, I better not give you guys too many details. 1/9 x plus 10 over 9. And just subtract 2. Minus 2, minus 2. So 2 times 9 is 18, guys. So 2 is the same thing as 18 over 9. But remember, we're subtracting. So 10 minus 18, that's negative 8. So y equals 19x minus 8/9. How are we feeling, guys?